Section: Introduction. In this section, we examine how large reasoning models, LRMs, address challenges that have long affected machine translation, MT. We focus on two key tasks: stylized translation and document-level translation, along with the integration of multimodal reasoning. These tasks have historically been used to assess MT systems, and we demonstrate how LRMs, with their reasoning capabilities, provide innovative solutions while also introducing new complexities. Stylized translation requires us to generate translations that maintain the stylistic features of the original text, such as tone and genre. Traditional MT systems often depend on extensive datasets or post-processing techniques to achieve this. While large language models, LLMs, have made stylized translation easier through natural language prompts, their performance can be inconsistent, especially in zero-shot scenarios. Without clear instructions, LLMs may overlook the stylistic nuances of the source text, resulting in translations that lack cultural or contextual relevance. With LRMs, we first analyze the context of the original text, which enhances our understanding of the appropriate style for the translation. This reasoning ability allows us to grasp the original text's intent and select suitable words for the output without altering its meaning. However, this method can sometimes lead to over-localization, where the translation aligns more with the target language's norms than the original style. By directing LRMs to assess the format and style of the original text, we increase the likelihood of producing an output that, while stylistically appropriate for the target language, may stray from the original's essence. For instance, we illustrate this with a Japanese haiku translated into Chinese. While the translation adapts to a Chinese poetic format, it occasionally deviates from the strict syllable structure, favoring patterns more familiar to Chinese readers. This situation raises important questions about balancing the authenticity of the source text with the translation's accessibility and appeal in the target language. We also provide additional examples, such as translations of Spanish poetry, in the appendix. Section Summary. In this section, we explore how large reasoning models, LRMs, address long-standing challenges in machine translation, MT, particularly in stylized and document-level translation, by leveraging reasoning abilities to better preserve stylistic features and contextual nuances. We highlight the potential for LRMs to enhance translation quality while also noting the risk of over-localization, where translations may prioritize target language norms over the original text's authenticity. Section: Document-Level Translation. In this section, we discuss document-level translation, which has been a long-standing challenge for machine translation, MT, systems. The difficulty lies in maintaining consistency, coherence, and style across longer texts. We face issues like unifying keywords, resolving pronouns, and keeping a consistent tone. While large language models, LLMs, have improved in this area, reasoning-enhanced models, LRMs, take it further by using their reasoning skills to better understand and unify context throughout sentences and paragraphs. For example, LRMs excel at consistently translating key terms, clarifying ambiguous pronouns, and adjusting the tone to fit the conventions of the target language. We illustrate this with a scientific abstract translation, where DeepSeek R1 not only keeps terminology consistent but also matches the formal tone expected in Chinese academic writing. In contrast, we see that non-reasoning models often misuse certain phrases and struggle with stylistic norms. LRM's ability to reason about context allows them to manage complex narrative structures, like those in novels or legal documents, ensuring logical flow and coherence, which traditional MT systems often fail to achieve. Next, we explore multimodal reasoning in translation. The inclusion of various inputs, such as images or audio, has broadened MT capabilities. LLMs like GPT-4o can translate text while considering visual or auditory context, leading to more accurate translations. For instance, an image accompanying the sentence, "Ta zui kan bao di," helps clarify whether the subject is reading a physical or digital newspaper. This multimodal approach helps resolve ambiguities that text alone cannot. LRMs enhance this further by incorporating reasoning into the translation process. Unlike traditional LLMs that rely on pattern recognition, LRMs can understand relationships between text and non-text inputs, allowing for deeper contextual comprehension. We demonstrate how LRMs use visual context to clarify translations, showcasing their ability to handle complex scenarios. However, challenges remain, especially with specialized inputs like sign language or specific visual content. We suggest that future research could integrate domain-specific knowledge, such as sign language dictionaries, to improve LRM capabilities. As LRMs introduce reasoning into MT, they also present new challenges and opportunities. We examine characteristics like self-reflection and the use of an intermediate language during translation, while identifying areas for improvement. One key advantage of LRMs is their self-reflection ability during translation, which helps them identify and correct errors, especially in ambiguous or noisy inputs. For example, when translating the ambiguous Chinese sentence, Bu huo de shi lai ren, DeepSeek R1 initially interprets it as, the hunter is the one who hunts, but through self-reflection, it considers an alternative meaning. The one who captures is the hunter. This iterative process shows LRM's potential to refine translations dynamically, although more research is needed to understand this capability fully. Self-reflection also helps LRMs manage noisy or incomplete inputs, allowing them to infer intended meanings and produce coherent translations, which is crucial in real-world applications. We also observe a behavior in LRMs called auto-pivot translation, where they automatically use a bridge language during translation without explicit instructions. This occurs when LRMs translate through a high-resource language, like English or Chinese, to translate between less resourced languages. For instance, when translating from Irish to Chinese, an LRM might first translate the Irish text into English before generating the final Chinese output. This reliance on high-resource languages aids in handling low-resource language pairs but raises questions about the transparency and efficiency of the process. While auto-pivot translation can enhance fluency and coherence, it may also lead to inaccuracies or loss of meaning, particularly with idiomatic expressions or culturally specific terms. The choice of pivot language can significantly affect the final translation, as different languages may capture different nuances of the source text. Section Summary. In this section, we discuss the advancements in document-level translation and multimodal reasoning in machine translation (MT) systems, highlighting how reasoning-enhanced models (LRMs) improve consistency, coherence, and contextual understanding compared to traditional models. We also explore new challenges such as self-reflection and auto-pivot translation, which allow LRMs to dynamically refine translations and utilize high-resource languages as intermediaries, though these methods may introduce complexities and potential inaccuracies. Section: New challenges beyond conventional translation. In this section, we explore unique challenges that extend beyond traditional text-to-text translation tasks. We focus on the ability of language representation models, LRMs, to handle encoded or ciphered text, which requires both linguistic understanding and cryptographic reasoning. This scenario tests the limits of LRMs in deciphering and translating intentionally obfuscated text, revealing their reasoning capabilities and limitations. When it comes to deciphering encoded text, one of the strengths of LRMs is their ability to tackle complex tasks. For instance, when faced with a Caesar cipher, where each letter is shifted by a fixed number, LRMs can often figure out the shift and decode the text without needing explicit instructions. However, their performance drops significantly with more complex ciphers, like the Vigenère cipher, which uses a keyword for shifting letters. Without a known key, the task becomes much harder. For example, when given the encoded text, MWSIMP-QVPMSS, which translates to, "Together we go," using the key, time, the LRM struggles to find the correct key and may produce incorrect outputs instead. This behavior shows a key limitation of LRMs. They can generate plausible but wrong answers when faced with tasks that exceed their reasoning abilities. This highlights the challenges of using LRMs for tasks that require advanced problem-solving skills in addition to linguistic understanding. Our exploration of LRMs in machine translation, MT, reveals both their transformative potential and inherent limitations. LRMs mark a significant improvement over traditional MT systems, especially in reasoning about context, culture, and intent. However, their performance varies across different tasks, indicating a need for further research and refinement. One of the main strengths of LRMs is their ability to manage complex translation tasks, such as stylized and document-level translations, by utilizing their reasoning capabilities. They can maintain stylistic features and coherence in long documents, which have been challenging for traditional MT systems. Additionally, their self-reflection abilities allow them to refine translations iteratively, enhancing accuracy in ambiguous situations. These advancements make LRMs powerful tools for applications like low-resource language translation and interactive translation. Despite these strengths, LRMs face limitations that hinder their broader use. A significant challenge is their performance in complex reasoning tasks, such as deciphering Vigenère ciphers without a known key, where they often produce incorrect answers instead of acknowledging uncertainty. The use of intermediate languages in translation can also introduce biases or inaccuracies, especially when translating between less resourced languages. Furthermore, while LRMs show promise in using visual or auditory context for disambiguation, their performance in specialized areas, like sign language interpretation, remains limited, suggesting a need for domain-specific training and external knowledge integration. Another practical challenge for LRMs is their inference efficiency, particularly due to the long chains of reasoning they generate. While this reasoning helps them tackle complex tasks, it can also slow down processing and increase resource use. This inefficiency can be a barrier for real-time applications, such as interactive or live multimodal translation. To improve this, future research could focus on optimizing reasoning generation by eliminating unnecessary steps and applying techniques to reduce the computational load without sacrificing performance. Enhancing inference efficiency will be crucial for scaling LRMs to real-world applications where speed and resource constraints are vital. Section Summary. In this section, we explore the challenges LRMs face beyond traditional translation, particularly in deciphering encoded texts like the Vigenère cipher, where they struggle to deduce keys and may generate incorrect outputs. While LRMs excel in reasoning and handling complex translation tasks, their limitations in ambiguous scenarios and inference efficiency highlight the need for further research to enhance their capabilities. Section: Future Directions. In this section, we summarize that while large reasoning models, LRMs, mark a significant advancement in machine translation, MT, we have yet to fully harness their potential. Our future research should aim to enhance their reliability in complex reasoning tasks, improve their handling of uncertainty, and broaden their expertise in specialized areas. Additionally, we must address the efficiency of inference to support real-time and resource-saving applications of LRMs. By overcoming these challenges, we can further expand the possibilities of MT and facilitate new uses in cross-cultural communication and more. We also present experimental results comparing various large language models, LLMs, with and without reasoning capabilities in translating Chinese to English while considering common sense understanding. We evaluate these models using BLEURT and COMET metrics. Our findings indicate that there is no significant difference in the automatic evaluation scores among the 4 models we tested. However, upon closer inspection of the translations, we noticed that a model might receive a lower COMET score despite producing a correct translation, simply because it used different wording than the reference translation. For instance, the sentence, Zheng Zai Kai Shou de Shi Guo Yuan Li de Guo Nong, was translated by DeepSeek R1 as, "The orchard farmers are harvesting," earning a COMET score of 0.7748, while DeepSeek V3 translated it as, "The orchard farmers are currently harvesting the fruits," which received a score of 0.8039. Although DeepSeek R1 may have provided a better translation, its score was lower due to the scoring system favoring translations closer to the reference. We believe this discrepancy arises because COMET and BLEURT rely on reference translations for scoring, which can disadvantage reasoning models that produce more varied outputs. To address this issue, we suggest that future work should develop new automatic scoring metrics that can better evaluate such situations.